All right. In the examples we've looked at so far, our force has been constant, and that force was gravity, and gravity is a constant force. What if force is not constant? Then we need to integrate. Okay, so if the force is not a constant, it's moving, we want to integrate the force that we have, our force function, uh, through the distance. So we're taking all those partial work values from 1 to n as the number goes to infinity. As an integral, again, we got our force function here, times our distance from A to B. So the work done in moving the object from A to B is integrating the force along that. Let's look at an example. So when a particle is located x feet from the origin, a force of x squared plus 2x pounds x on it. You can see that is not constant. That's a variable force. Depending on what you put in for x, you get different values there. How much work is done in moving it from 1 to 3? So we want to set up an integral here to do this one because it's not constant. So we got to integrate from a to b our force function through the amount of distance we're moving it. So here our force function is x squared plus 2x. We're integrating that from 1 to 3. And if we do that, that should give us our amount of work done. We've done these integrals now before. Find your antiderivative. We're going to evaluate it now at from 1 to 3. So if we put 3 in there, we're getting 1/3 of 3 cubed, which is 27, so that'd be 9. Plus 3 squared is another 9. Minus what we get when we put in 1, which should be 1/3 plus 1. And doing that, we get 18 minus 4/3. And if we subtract that, we are going to get, it looks like 50/3 here. And that, since we're in pounds here, and this is the amount of feet that we're moving this would be in foot pounds. Should always label on these ones so we know what we're working. All right, let's take a look at another one. A force of cosine cubed x sine x newtons is applied to an object and moves it pi over 2 meters from the origin. Find the amount of work done. So again, we're setting up an integral here. Or from the origin means we're starting at 0, moving it to pi over 2. Our force function here would be cosine cubed x sine x dx. All right, so now we got to integrate this. This one, we got two functions being multiplied here. Probably tells us that we're not going to be able to just find the antiderivatives of both since they're being multiplied. This one definitely looks like a substitution problem here. The one where we got a function and aside another function there is our cosine being cubed there. So we want to set it our substitution to the inside one, which would be the cosine. So cosine x. Our derivative then would be negative sine x dx. So if we substitute here, looks like our sine x dx would then substitute as a negative du. And then cosine becomes our u. So our integral, we're going to have this extra negative. Cosine turns into u cubed, and all that turns into our du, the sine x dx. I'm going to, at the same time here, let's do it the way where we change our limits on these two. So what do we get if we were to do cosine of 0? That's our x value on the unit circle at an angle of 0. So that would be right here. Our x value there should be 1. So cosine of 0 is 1. If we do cosine of our other limit, pi over 2, that's at 90 degrees. That's our x value there. That should be 0. So these would, our limits would change from 1 to 0. Looks like now that we had switched those, they're out of order. I'm gonna flip those back, which should change this integral then to negative to positive. So now we no longer have that negative out in front of there. This antiderivative's pretty simple here. So we get 1/4 u to the 4th evaluated from 1 to 0. I don't need to substitute back in because I've already changed my limits. And so this would be 1/4. If we plug 1 in, if we plug 0 in, it's 0. So it looks like here we just get 1/4. And this was in newtons, moving it in meters. So that's a measurement called joules. So answer would be 1/4 joules. That's the amount of work done on this one. All right, one more. Why don't you try this? Try this next one out here on your own, and we'll check it here in a second. All right, hopefully you've had a chance to try here. The amount of work force was given by this function, and we're trying to move it from 0 to 8 because it's from the origin to 8 meters. This one, probably want to use some substitution here. Our inside functions, x plus 1. Also, we can take our constant here and drag it out. So if we do that, we end up with this integral here. I also changed those limits right away here. So 1 and 9 instead of 0 and 8. Probably want to move that up to the numerator to integrate. So it'd be u to the negative 3. So when you find the antiderivative, we want to go up 1 with our power there, with our reciprocal in front. We still got that 7 there. So now we got negative 7/2. I moved that negative 2 back down to the denominator to make it 1 over u squared. So plugging in 9, we get 1 over 81. Plugging in 1, we get 1. And if you multiply or subtract and multiply, we end up with 280 over 81 joules.